Hello, everyone, and welcome to today's webinar. My name is Mitch Mershon, Senior Product Marketing Manager here at Keyfactor, and I'm riding shotgun with Steve and Dave from Quside, and they're going to be talking about securing the future of PKI, quantum-ready entropy for cryptography. And this is the first installment of our Tech Alliance Partner webinar series, where we're going to be double-clicking in on some very specific topics as they pertain to cryptography and PKI. So again, this is the first. Make sure that you sign up for the rest of them. We'll be coming out weekly, so you'll be able to get your new technology fix every week for the next few weeks. Just some basic housekeeping items. Please feel free to type into the Q&A. We will answer those as best and as fast as we possibly can. And over on the right-hand side, you also have some resources available. So if you want to find out some more information or get connected with either Quside or Keyfactor, we've got some information there. So without further ado, I'll hand it over to Steve and Dave.
Hello, everybody. Thank you for joining us today. My name is Steve Tahkar. I'm the Chief Revenue Officer for Quside Technologies SL, and I'm joined by my colleague, Dave Worrall, who is Head of Customer Solutions and Quality Assurance at Quside. And today we're going to be talking about securing your PKI infrastructure from a quantum perspective and the threats that are evolving at the moment. What I will do is we'll share a presentation with you as we go through. Dave, over to you, if you just want to say hello to the viewers.
Hi, good day to everybody joining us on this call. I hope you find it informational, and any questions, anything, please reach out and let us know.
Great, thank you, Dave. Right, without any further ado, let's start. Let's kick off, Dave. We both know, and our peers know, that entropy is the core foundation of cybersecurity infrastructures. In your eyes and your view, how important is entropy in cryptography, and what might the ramifications be of poor entropy?
Well, as we say, Steve, in cryptography, it's all about deterministic algorithms. So what we have is we have a number of algorithms that we use, and obviously the idea is what I put in once, I can put in again and get the same result, which is how people break cryptography. The ability to duplicate what you did. Of course, the reason you can't duplicate it is because we use entropy. We use randomness to generate seeds, to generate key material that we put into these algorithms, and that produces our strong keys. Now, obviously, if somebody can guess what that key material is, somebody can guess that randomness, or if that randomness is not sufficiently random, then basically it becomes so much somebody to break your cryptography, regardless of which algorithm you're using, whether it be PQE, post-quantum, whether it be pre-quantum, it is a major problem. And as we've seen in the industry, and we've seen throughout a number of years now, more and more people are using that as an attack vector. You know, we had in 2022, as you see on the screen, we had this problem with Samsung, 100 million phones, 100 million plus, where they used very poor entropy. Cisco have a number of CVEs out on their equipment about this exact problem, where their equipment cannot generate sufficient entropy. Therefore, the randomness gets repeated. And if you think about it very simply, if I have 10 bits of randomness, say from numbers 0 to 10, if I have those bits of randomness and that's all I can use, then there are only so many permutations, and a small laptop would quite easily crack that key. So it's really important that the entropy is well managed, it's as good as you can get, and there is no repeatable patterns that somebody can use.
Okay, thank you for that, Dave. That was very useful. Moving further on, you've established the importance of entropy, of randomness, and also the creation thereof of random numbers. Now, how can users and our customers help differentiate between the different types of random numbers out there and classification? Over to you.
Yes, well, so Quside, along with Deloitte's, worked together with a number of other people in the industry to come up with classifications so that people can quite easily differentiate between different levels of randomness. Not all randomness generators are equal. We know, for instance, we have level 1, which is an illusion of randomness. these are deterministic algorithms. They are deterministic. They run on a lot of different machines, but at the end of the day, it's an illusion of randomness. We have opportunistic randomness, where we say, okay, what's the clock ticks, mouse movements, keyboard inputs, different things. And we've all seen this when you've tried to create keys for VPNs, type some things on your keyboard. But that is very limited randomness. And it's not really random because people tend to do the same things. So it's all about different levels about how do we get something which has sufficient entropy to be able to generate these keys. And where we are is what we class as a level 4, because it's not enough in cryptography just to say I'm generating good randomness. The next level requires metrology. It requires the ability to measure it and to verify that the equipment is working the way it's supposed to be working. So your randomness is always of the highest quality. Your equipment is always working. And where you're getting your randomness from is the source you think it is. And this is key. That is one of the key differentiators, and why with quantum, it's the only one we currently have that is able to actually be monitored, measured, and observable in real time. Yeah. So these are the different levels of randomness, and these are the things that people really need to start to understand. That's why we have QRNG, and it's why the people in the know are really pushing for QRNG type solutions for the cryptography.
Dave, thank you for differentiating the different levels of randomness, and also thank you for helping position where you believe Quside fits within these 4 levels. Just moving the discussion further on, how does Quside do its entropy? How can it manage that entropy? And what certifications are available that Quside is certified for at the moment?
So Quside develops photonic chips, right? Using quantum effects within lasers. And within that, we have a number of different scalable solutions. So we have our Ruby N1, which is a 1 gigabit per second. We have a number of other chips, which for lower proofs of entropy, slower speeds. All these chips can be used in various different ways. We have plug-and-play PCIe cards, our Garnet series, which can fit into servers, desktops, whatever you want, with a full set of libraries, integration tools that allow you to actually use them in your standard server hardware infrastructure. We also have Nelite series based on the same chipsets, and it allows you then, if you already have a product that has an FMC with an FMC infrastructure inside it, the proper connector with your own FPGA, you can really plug one of these in, and then your FPGA or your custom device can then make use of this entropy. And at the other end of the scale, for a very small thing, we have our Onyx series, which is basically 30 centimeter by 30 centimeter, 3 centimeter by 3 centimeter board, combining our chips and a small microprocessor that allows you to use various electronic interfaces such as SPI, etc., with this board and integration. This, of course, all of these come with the same metrology and the same generation of entropy from quantum sources.
Okay, thanks for the description of Quside technology and how Quside brings this technology to market in the different form factors. Now, I think we've established that no one organization in this post-quantum world, or soon to be post-quantum world, we should say, when quantum computing starts to become all pervasive, can actually do everything. Therefore, partnerships and indeed ecosystem is very important, and working with established vendors, certainly, for example, in the certificate market, in the key generation market. One of Quside's important partnerships is that with Keyfactor. From your perspective, how do you feel Keyfactor and Quside work together, and what advantage could that mean for our customers? In other words, how would you describe the joint Quside and Keyfactor joint value proposition?
I think, as you can see from the slide, we've integrated at the very core of the Keyfactor cryptographic primitives in with their core cryptography suite. This is a very simple deployment. You put our card in, you put one of our devices in, you make a configuration change. So there's no rip and replace. There's no major changes to existing infrastructure. There's just merely the addition of QRNG. And of course, we're NIST certified for SB 890A and B, and we are C compliant, and we will get that certification once it becomes available. This, of course, complements the Keyfactor FIPS 140-3 solution, meaning you have a fully NIST certified solution end to end. And this is really key for people who care about this. So leveraging our partnership with Keyfactor, leveraging their expertise in FIPS and cryptography, we're able to give them a fully end-to-end, any customer, a fully end-to-end, NIST certified, fully quantum RNG supplied system. Of course, what do we bring to the party? We're bringing our observable and measurable entropy, right? So basically, users can say, I want a min entropy level of 0.96, 0.97, 0.98, a min entropy level being a measure of entropy. And you can ensure the card is actually working to that capability. Yeah. And we're ensuring there's no entropy starvation, as we discussed earlier. Entropy starvation, where systems can't generate enough entropy, is a major problem. It leads to weak entropy, it leads to holes. So we bring to the Keyfactor solution the ability to integrate QRNG and to ensure you have no entropy starvation and full manageability and observability across your stack. Of course, what do we get from Keyfactor? We get the full utilization of all the Keyfactor ecosystem, which provides us with scalability and a fully managed PKI infrastructure. And as you know, Keyfactor are expanding that portfolio and moving into different areas, which means as a product offering, we can now cover full cryptographic PKI infrastructure space. So working together, you have a next generation ecosystem that is ready to support whatever your product requirement is.
So Dave, are you inferring that Quside and Keyfactor have a fully integrated solution?
Yes, we have a fully integrated solution. There is an integration guide. It's very simple and straightforward. As I said, it's loading a couple of libraries and then making 1 or 2 lines of configuration change to your existing infrastructure or indeed your new infrastructure. And that brings QRNG to the suite of Keyfactor products.
Now that's very useful and that's good to see. But ultimately, as we both know, in the post-quantum world and era, we need to look at specific use cases that have a business case attached to them, etc. So would it be possible for you to take us through a use case for this type of integrated solution?
Yes. I mean, one of the use cases we have worked on is on smart cities. It works for IoT, MIoT, IIoT, code-edge smart cities. So at the moment, we have devices out there which basically are controlled from a central location. And they basically communicate over secure channels back to a data server. A lot of this is not really protected. Some of it is HTTPS, some of it is not. Some of it uses higher level protocols over the TCP/IP, which are not really protected. And the edge devices, be it SDVs, be it IoT devices, they're not really capable of being protected because they can't generate entropy. So how do we generate entropy certificates, keys, and manage all of this moving forward? So what we do, and this is where Keyfactor's product range comes in, where you have your big PKI infrastructure, Keyfactor infrastructure with your servers and everything in your core, where you're generating certificates and you're generating all of that, yeah, we can fully integrate with that, which means you can use whatever FIPS certification you require. If you require PQC algorithms, of course, Keyfactor now support all 3 of the current PQC algorithms, and we, of course, support them by providing the entropy. However, also key is the ability to generate this entropy out in the edge device. Because these days, as people know, when you're on public transport, you Wi-Fi, you want to use hotspots. If you travel in your car, and I don't suggest you do it while you're driving, if you put your phone on, every time you go past somebody's car, you'll be offered a hotspot. Yeah, it needs protecting like never before. It's no longer a point-to-point. It's a fully meshed network we have out there. In industrial situations, we have many thousands of sensors talking to a central point, which then goes to a major control center. So what you need there is you need the entropy to be able to be generated at the edge. So you can generate symmetric keys, etc., very, very securely. Yeah. So basically, the ability to be able to put a Quside system on board on these devices, as well as have your full protection at the core, is really key to moving forward. And as you've seen, Steve, and we have seen in one or two places where we're actually doing this and we're integrating with it at this sort of scale, is where the PKI, the Keyfactor PKI tools really come in useful. The ability to manage this at scale and to be able to know what's going on, where it's going on, and continually manage and monitor with the integration of our QRNG monitoring is really key to these solutions going forward. Where we don't have one or two to manage, we have many hundreds of millions of endpoints. And that's where the key differentiator is. The ability to push PQC out there, push QRNG out there, and really start to secure what is becoming a more and more decentralized infrastructure.
Dave, thank you for your informative insights. I think that's very useful. I think it gives a very good description of real life scenario of how Quside and Keyfactor coming together can start to basically quantum secure PKI infrastructure for our customers. So that's a potential call to action to everybody. If this is of use to you and this is something that you'd like to look further, then please contact either Quside or Keyfactor, and we can start to engage with you to see how we can maybe bring some of these solutions in your infrastructure to life and start to give you that post-quantum security. Thank you for your time, and we look forward to meeting potentially with you soon.
All right. Thank you very much, Steve and Dave. That was some great information. And even having been around PKI for a little bit, the idea of quantum ready entropy still kind of boggles my mind. But I also now understand much better about why it is such an important thing as we move forward with all the different technologies that are happening. So, again, thank you to Steve and Dave, and thank you all for attending today. I want to make sure that you also tune in to our other sessions. This is again part of our Tech Alliance Partner webinar series. And our next topic is also going to be around the future of proven quantum randomness. So make sure to tune in, get signed up, and see the rest of our series. Thanks again.